In this lecture, we are going to consider another example under the direct variation, and the example is just shown on the screen here. We are told that x minus 4 varies directly as the square of y, and x equals 7 when y equals 1. Find the value of x when y is equal to 3. That is the question that we have in front of us. And I told you that the first step we are going to take is to write the relationship between the given quantities. Okay, we were told that x minus 4 being the first quantity varies directly as the square of y. That is the relationship. And I said to solve this further, we have to eradicate the variation sign and then introduce the equality sign. And while introducing the equality sign, we have to add or introduce also the proportionality constant. And in most cases, we use the letter k. So to do this, we have x minus 4 is equal to k y raised to the power of 2. Let us call this equation 1. Call this equation 1, right? Now, we can decide to make k the subject of the formula. And if we do that, we have that k is equal to x minus 4 all over y squared. But we're told in the question that we have when x is equal to 7, we have y to be equal to 1. So we can use these parameters to find the value of k. So we have that k will be equal to 7 minus 4 all over 1 squared. And then we have 3 over 1. 1 squared is equal to 1. Okay, so the answer here is 3. So the value of k is equal to 3. The value of k is equal to 3. Then the next step is to substitute this k's value into equation 1. And if we do that, we have our equation 1 to be x minus 4 is equal to ky squared. And we said from the previous slide that k is equal to 3. If we substitute the value of k, we have x minus 4 is equal to 3y squared. From the question as well, we're told that we should find the value of x when y is equal to 3. So when y is equal to 3, x is unknown for now. So we can decide to add plus 4 to both sides in order to eradicate the constant 4 on the left hand side. Sometimes you can say take minus 4 to the other side of the equation and it is still the same thing. All right, so if we add 4 to both sides, we have x minus 4 plus 4 is equal to 3y squared plus 4. And the reason why we did that is so that these can cancel out and we are left with x alone on the left hand side. So x will then be equal to 3y squared plus 4. But we were told y is equal to 3. So if we substitute the value of y into this equation that we have, we can say x is equal to 3 into 3 squared plus 4. So this gives 3 times 9 plus 4. 3 times 9 is 27, and 27 plus 4 gives us the value of x, which is equal to 31. And this is our final answer. All right, so this is the end of the class on the examples of direct variation. And I'm sure by now you should be able to solve any problem that pertains to direct variation. In our next class, we'll talk about the second type of variation, which is the inverse variation. Till we meet again, bye.